Welcome to the first tutorial on Network and Integrated Management. My name is Sebastian Seeber. I'm PhD at the University of the Federal Armed Forces in Munich. In this tutorial you will get an overview of management definitions in the first part and management scenarios in the second part. Let's start with the question, what is integrated management? An integrated management system is a management system that integrates all, for example, organizations, systems and processes into one complete framework, enabling an organization to work as a single unit with unified objectives. With an integrated management system you get a unified whole with each function aligned behind a single goal, improving the performance of the entire organization. Instead of, let's say, silos, you have a real coordinated system, one that's greater than the sum of its parts, and which can achieve more than before. An integrated system provides a clear, holistic picture of all aspects of your system, how they affect each other and their associated risks. There is less duplication and it becomes easier to adopt new systems in future. An integrated management system allows the management to create one structure that can help to effectively and efficiently deliver the organization's objectives. From managing employees' needs to monitoring competitors' activities, from encouraging best practice to minimizing risks and maximizing resources, an integrated approach can help an organization achieve their objectives. Now we know what integrated management in general is. But every time you hear management, it seems to be a complex task. Let's think about the reasons for that. One reason is the heterogeneity. Heterogeneity in conjunction with an increasing number of devices will also increase the complexity of the system. As you can imagine, if you have only a small amount of devices, you can manage them in a straightforward way. But also in this case the complexity can increase if you use the diversity of different hardware platforms in your devices, which will mostly not work together out of the box. This aspect amplifies if you apply additional software components on your devices. Most applications need a variety of values from other sensors or applications. These values are distributed across the various components, which also increases the complexity of the management task. As you can now imagine, management is quite a complex task even if you have only a small amount of devices. In general, you have greater amount of networks and systems, applications, services, hard and software like firewalls, web servers or mail servers, where the information and functionality is distributed across various components. As you can see, we have to manage heterogeneous, distributed, complex and large environments. If we have to manage such a great amount of things, is network management only a great chaos? It seems to be so, but like in every chaos we can organize it. There exist different models to arrange the chaos and make it manageable. One is defined by the ITU-T. The ITU-T mission is to ensure the efficient and timely production of standards covering all fields of telecommunications on a worldwide basis, as well as defining tariff and accounting principles for international telecommunication services. They defined a management hierarchy reference model which describes the telecommunications management network mentioned in the standard. Because management is a multi-layered and multi-dimensional problem space, the model proposes to structure the management according to the managed objects, for example network devices, end systems, applications and services. As mentioned in the last slide, the Telecommunications Management Network, TMN, is a protocol model defined by the ITU-T for managing open systems in a communication network. It is part of the ITU-T recommendation series M3000 and is based on the OC management specifications in ITU-T recommendation series X700. Now I will describe the management pyramid. which is based on the TMN protocol model. This should help us to get order in the chaos of management. The pyramid consists of 6 layers. I will describe these from the top to the bottom. The first layer, called Business Management, describes the management of the business itself. It is associated with providing services and all support functions. The second layer describes the customer management, also called customer relationship management. This includes all aspects like marketing, customer services and support, appointments, small business, for example managing contacts, emails, relationship tracking and so on, and social media. The next layer describes the service management. It refers to the implementation and management of quality, for example information technology services, and is performed by service providers through people, processes and information technology. Concerning the IT service management, we can say that it is process focused and has ties and common interests with process improvement frameworks and methodologies. It is not concerned with the details of how to use a particular vendor's product or necessarily with the technical details of the systems under management. Instead, it focuses upon providing a framework to structure IT-related activities and the interactions of IT technical personnel with business, customers and users. The fourth layer is the distributed system management, which describes the management of the end system and the whole distributed system. Possible facts which have to be managed are the expected or the provided values of the end systems. The next layer is called network management. It describes the management of the relationship and dependencies between the network elements. It refers to the activities, methods, procedures and tools that pertain to the operation, administration and provisioning of networked systems. It is generally carried out of a network operations center, which commands and controls practices. To characterize network management functions, in most cases FCAPS is used, which describes fault, configuration, accounting, performance and security. The element management is the last layer of the management pyramid. It describes the management of the individual devices of the network, not the traffic and connections between them. It handles the elements including alarm management, backup, logging, and maintenance of hardware and software. A single network element provides agent services mapping the physical aspects into the TMN network. Now we know what management is and how it can be organized by models. This leads us to some examples of management scenarios. The first is the DNS management. The domain name system is a distributed system for naming of computers, services or other resources connected to the internet or a private network. Prominently, it translates memorized domain names to numerical IP addresses to locate computer services and devices worldwide. DNS management could be divided into conceptual and operational aspects. The conceptual aspects are more organizational issues, like the definition of the naming conventions or the specification of the naming space. Another aspect is the structure of the name service in your own private network or the internet. For the purpose of redundancy and failure recovery, you have to think about these aspects. The operational aspects cover the configuration of the resolver in the end system and the operation of the name service. The maintaining and updating of the naming space is also an operational aspect, which has to be included in the DNS management. The next slides describe 3 complex service provider hierarchies as examples of management scenarios. The first slide explains the service provider hierarchy from the provided services by research organizations like Max Planck Institute or other institutes from Munich to the internet. In the first step, the organizations provide services to the Munich scientific network. The providing of these services to the Munich scientific network is guarded by specified service level agreements, which build the interface between the services and the business. There the provider guaranteed the accessibility of the services. The Munich Scientific Network is a part of the network from the Leibniz Rechenzentrum. This is connected to the German research network provided by the DFN and again guarded by special SLAs, which guarantee the provision of proposed services. The same again exists between the German research network and the backbone from the T-Systems, which is a national internet provider. This slide describes the German scientific network. Deutsches Forschungsnetz, German scientific network, usually abbreviated to DFN, is the German National Research and Education Network, used for academic and research purposes. It is managed by the scientific community organized in the voluntary association Verein zur Förderung eines deutschen Forschungsnetzes e.V., which was founded in 1948 by universities, non-university research institutions and research-oriented companies to stimulate computerized communication in Germany. DFN's supercore backbone X-Win network points of presence are based in Erlangen, Frankfurt, Hanover and Potsdam. These sites run Cisco CRS-1 routers and are interconnected with each other by two 10 gigabit Ethernet connections. All upstream connections are 10 gigabit Ethernet based and are implemented at the supercore. All other routers on the network are Cisco 7609 based and always linked to two other network routers. GEAN is the pan-European data network for the research and education community. It links national research and education networks across Europe, enabling collaboration on projects ranging from particle physics to medical research and the arts. The project combines a high bandwidth, high capacity 50,000 kilometer network with a growing range of services for users. These allow researchers to work together wherever they are located. Services include multi-domain monitoring, like Personal MDM, dynamic circuits, and roaming via the eduroam service. Together with European NRENs, GEAN connects 40 million users in over 8,000 institutions in 40 countries. Through links to research networks in other regions, such as Internet 2 and SNet in the US, TANE in Asia Pacific and Clara in Latin America, GEAN allows collaboration between researchers on over 16 NREN outside of Europe. The next management scenario is a virtual private network. A virtual private network, VPN, extends a private network across a public network such as the Internet. It enables a computer to send and receive data across shared or public networks as if it were directly connected to the private network, while benefiting from the functionality, security and management policies of the private network. This is done by establishing a virtual point-to-point connection through the use of dedicated connections, encryption, or a combination of the two. A VPN connection across the Internet is similar to a wide area network link between the sites. From a user perspective, the extended network resources are accessed in the same way as resources available from the private network. VPNs allow employees to securely access their company's intranet while traveling outside the office. Similarly, VPNs securely and cost-efficiently connect geographically disparate offices of an organization, creating one cohesive virtual network. VPN technology is also used by ordinary Internet users to connect to a proxy service for the purpose of protecting one's identity. What are the reasons why virtual private networks are used? There are three main aspects why virtual private networks are used. The economic aspect cover the elimination of the need for long-distance leased lines, which include the reducing of long-distance telephone charges. Because if you have a VPN connection to a branch of your organization, you can use the VPN for data and voice messages as well. For the establishment of a VPN, you have high fixed costs for the appropriate hardware but low dynamic bandwidth dependent costs, which allows you to estimate the cost for the VPN in a detailed way. The next aspects focus on the quality and security. By introducing a VPN technology, you can establish different VPN connections concerning the quality of service, security and privacy aspects. That means you can differentiate between the different requirements for the department which are connected via VPN, the users and the provided services. That aspect gives you more flexibility as leased lines. The last aspect covers the addressing and routing in a virtual private network. The use of a VPN allows you to apply the same addressing scheme in all your connected departments. Additionally, you can define routing policies as desired. For example, if your departments are connected with each other and not only centralized to the headquarters, you can think about a routing policy that leads your traffic through a department which is connected by a higher bandwidth. Virtual private networks consist of three types. The first type is the ExtranetVPN, which is used as an extension for your internal network of your organization to the sites. It connects the headquarters with the settlements and other departments. The next type is the ExtranetVPN. It is used to connect the customers, suppliers and partners to the intranet of an organization. This VPN is mostly used for support connection issues by contractual partners. The last type is the ExtranetVPN, which allows mobile users the connection to the intranet or extranet of a company. This functionality can be used by home office users or fieldwork users. In the following I will describe the three types of virtual private networks. The intranet VPN is built up between different departments of an organization. In this case, the connection is only encrypted between the VPN gateways. Here we see three VPN gateways which are fully connected. In detail, a VPN gateway only consists of a router plus some additional functionality because the VPN is built up in the gateway and the router has to send the traffic which is expected for the VPN through it. All connections in this virtual private network are working in the tunnel mode. For this reason, the VPN is transparent for all systems and the departments which establish a connection with each other. The next type is the extranet VPN. The extranet VPN connects locations of several companies. For example, the ENX, which is an extranet virtual private network for the car industry. The ENX Association is a non-profit organization that acts as a legal and organizational roof for the ENX network standard. It provides the participating companies with a platform for the exchange of information and for the initiation of pre-competitive project cooperations in the field of information technology. The network can be used for all IP-compatible protocols and applications. The bandwidth ranges from classic EDI data exchange to access the databases and secure email exchange to the carrying out of video conferences. The use of EDI transfer protocols such as OFTP, Ordered File Transfer Protocol, OFTP2 and AS2 is widespread in the ENX network. OFTP2, which was developed from 2004, allows for use via the public internet. In March 2011, over 1,500 companies within the automotive and the other industries were using the network, which is available worldwide in over 30 countries. The last type is the access VPN. The so-called remote access VPNs allow employees to access their company's intranet from home or while traveling outside the office. The slide shows the process of establishing such a connection. In the first step, the laptop has to be connected to the internet over a provider. In the second step, the VPN client connects to a VPN server, where the client has to supply the authentication data for the VPN server. Step 3. In the fourth step, the tunnel between the VPN client and the VPN server is established. After the tunnel is established, a secured connection between the laptop and the corporate network is possible. Now we are at the end of our first tutorial on integrated network management. I hope you liked the presentation. If you have any further questions which are not covered by our tutorials, please contact us via email or video answer. Bye.